Uh, what makes the night sky so dark? If there's so many stars in the sky, why can't we see their light at night? Why is the world shrouded in darkness? These are the central questions surrounding Olber's paradox, which we'll walk you through today. I'm Arnav P.
I'm Shripal S.
And I'm Abhinav Y. So here's our table of contents. First, we'll go over what the Olber's paradox is, then we'll go over some history, and then we'll give an explanation, and then we'll show our citations. So what is the Olber's paradox? One of the most puzzling questions for astronomers of the old was why the night sky is dark. Under the assumption that the universe was static and the numbers of stars were infinite, it would only stand to reason that there would be stars in every direction of the night sky. And as a result, the night sky would have to be bright, right? Because it would only be like natural for light to be seen in every direction if like all those stars emitted light. And then we have this model to the right that could potentially show what would happen if there were like truly stars that we could see in every direction. The entire screen, as you can see, would be completely filled with light.
To answer that question, we need to go way back to the start of the universe. The general consensus by virtually every physicist out there is that the universe started with a Big Bang. About 13.8 billion years ago, the universe existed just as a single point, a singularity. From that, somehow, in some way, the universe started to expand. It was incredibly hot at first. Everything was incredibly close together. But as it grew bigger and bigger, the energy spread out over the large distances that the universe was beginning to take, and it began to cool. Stars and other structures soon began to form afterwards. Now we know that the universe is at least 93 billion miles across. Why do I say at least? Well, light takes time to travel. It might seem instantaneous, but light travels at a certain speed, 3 times 10 to the 8th meters per second. So the only information we have about the universe is the information that light tells us. And light coming from the distant reaches of the universe has only come to us from around 13.8 billion years out. And from that, we've calculated that the visible universe, everything that we can see, is 93 billion miles across. But we don't know anything beyond that. Everything that we've looked at the universe shows that it's non-repeating and it's flat and planar, but we don't know what's beyond that. The universe could end right at 94 billion miles across, or it might continue on for 100, 200, it might be infinite. We don't know.
So the evolution of proposed solutions to this paradox originated from the early 1600s. So the first proposed solution was theorized by Johannes Kepler. He suggested that the universe of stars extended finitely to a certain distance, and once our line of sight, which is the visible light spectrum, passes that distance, only empty space could be observed. In 1848, the first scientifically reasonable solution was proposed by Edgar Allan Poe, the writer. He wrote The Raven, if you know. He suggested that the universe is not old enough for the starlight of the farthest distances to reach us. Therefore, why the entire sky isn't luminous. So in the 1910s and 1920s, 2 theories became popularized. These were the steady state theory and the Big Bang theory, which was mentioned earlier. While the Big Bang theory suggested an explosion of a very condensed form of all matter, which is known as the singularity, which has been expanding ever since, the steady state theory suggests that the universe has always been expanding, but maintaining constant average density, with matter continuously being created. So with both theories proposing an expanding universe, the most widely accepted solution to this paradox is that every star which travels the speed of light, which mentioned is 3 times 10 to the power of 8, cannot reach the visible light spectrum where we can see the light emitted from that star, due to stars being present in very far distances from the spectrum. So their light has not traveled far enough yet. So because the universe is expanding, there will always be stars in very far distances from us. So infinite light can never be displayed. So as shown in the picture, that blue circle, the light blue circle, that's the boundary of the observable universe, so what we can see. And as you can see, there's a lot more beyond that. And there's stars that are concentrated a lot beyond that. So those stars have to travel more for us to see them. So because all the stars are not emitting light where we can see, there's not infinite light. So there's going to be dark spots in the universe. And here are citations.
Okay, so thank you for watching. I hope you guys learned something.
Thank you.
Thank you.